Moving to the next question. Which orbital gives an electron a greater probability being found close to the nucleus? Which is the atom, which is the shell which is closer to the nucleus? Yes, the S subshell will be closer to the nucleus as compared to P, D and F. So 3s is closer to the nucleus. So 3s is the correct answer, choice C. Next question. Hamiltonian operator H bar, Hamiltonian operator is the sum of two energy operators. Which are the two energy operators? That is kinetic energy and potential energy. Hamilton operator is the sum of kinetic and potential energy, that is choice C. Next question, students. Angular nodes in a 4s suborbit is equal to the radial nodes in. How do you find out angular nodes? I told you angular node is equal to L, that is azimuthal quantum number value, and radial nodes is equal to what I told you, n minus L minus 1. So now you decide for 4s suborbital, for 4s subshell, which is it equal to? It is both equal to 3d and 2p. Choice C is the correct answer. You have to do the calculation because similar type of questions we have already done many of them, okay, and I am telling you the formulas, substitution you do and then decide and verify that choice C is the correct answer. Okay, let's move to the next question then. Psi square at any point is proportional to what? Psi square at any point is proportional to your choice A itself, the probability of finding the particle at that point. Yes, that is the direct relation between psi square and finding the probability at that point. Okay, next question. Uncertainties in the measurement of momentum and position are equal, then uncertainty in the measurement of velocity is given as what? Uncertainty in the measurement of velocity is given to you as 1 upon 2m under root of h upon pi. That is the correct relation between delta x and delta p, or delta x and delta rho, that is probability of finding the position and momentum. Next question. For the two moving particles A and B, following values are given. Let us see what is given. Particle A and particle B, their velocities are given to you and their mass are given to you, students. So when velocity is known, mass is known using de Broglie's wavelength expression. What is de Broglie's wavelength expression? We know that lambda is equal to c upon m into v. So c is constant. What is c? Speed of light or velocity of light, 3 into 10 raised to 8. Mass for particle A, velocity of particle A is given. Find out lambda A and then find out lambda B using the same expression and you should get the ratio. Lambda A and lambda B, when you find out, the ratio between them should come as 5:2. Okay, moving to the next question. The wave number of the spectral line in the emission spectrum of hydrogen atom will be equal to 8 by 9 times the Rydberg's constant if the electron jumps from. That means you have to find out n1 and n2 over here using Rydberg's expression. Okay, Rydberg's expression, you have to find out 8 by 9 times it is given to you. You have to find out n1 and n2. So when you find out n1 and n2, n1 should be 3, n2 should be 1. That means from 3:1. Yes. Moving to the next question. Which one of the following constitutes a group of isoelectronic species? Which of the following constitutes a group of isoelectronic species? 4 choices are given to you. You can observe the choices very carefully, students. You have to decide first of all what is isoelectronic species. What your concept tells you? Species containing same number of electrons, same number of total electrons is known as isoelectronic species. Now look at choice B to verify it. In choice B you have NO plus, C2 raised to minus 2, Cn raised to minus 1 and N2. Find out the number of electrons, all of them will be 14 each. Calculate the number of electrons for NO plus, plus comes how? Loss of electron, 1 electron becomes loss because nitrogen is 7, oxygen is 8, total is 15, but NO plus 1 electron is lost, so becomes 14. C2, 2 carbons, 6 plus 6 is 12, minus 2 charge comes by gaining 2 electrons, so 12 plus 2 is 14. Cn minus, carbon has 6, Nitrogen has 7, 13, 1 negative charge by addition of electron makes it 14, and N2 in the molecular state has 14. So choice B, all are isoelectronic species. Moving to the next question. In an experiment reproducing the measurements of Rutherford and his co-workers, that is 22 into 10 raised to minus 3 milligrams of helium was collected in 1 year from a sample of radium. This sample was observed to emit 1.06 into 10 raised to 11 alpha particles per second. Thus Avogadro number is, okay, what will be Avogadro's number? We know that Avogadro number of particles will be equal to 6.08 into 10 raised to 23 per mole. Moving to the next question. Medical experts generally consider a lead level of 30 milligrams. Lead level is 30 milligrams of lead per deciliter of blood to pose a significant health risk. Atomic mass of lead is 208. Number of lead atoms per centimeter cube of blood. You have to find out number of atoms of lead per centimeter cube. Mass is given to you as 30 milligrams. Convert that milligrams in terms of grams. So once you convert milligrams in terms of grams, then divide by the atomic mass 208, you will get number of moles of lead. But that many number of moles of lead is present in deciliter. Deciliter is what? 0.1 liter. So 0.1 liter will be how many centimeter cube? 100 centimeter cube. So you have number of moles, that is 30 milligrams converted in terms of grams, divided by the atomic mass 208 will give you number of moles first. Number of moles multiplied by, okay, number of moles multiplied by Avogadro's number, that will be for 0.1 liter, or 0.1 liter is nothing but 100 centimeter cube. Divide by 100 to get the answer for per centimeter cube. For per centimeter cube, it should come as 8.68 into 10 raised to 14 atoms. So number of atoms present in blood of lead per centimeter cube of atom has to be determined using the mole concept relation. Moving to the next question. Which hydrogen-like species will have same radius as that of Bohr's orbit of hydrogen atom? Okay, which of the following species will have similar Bohr's orbit of hydrogen atom? Hydrogen atom has 1 electron. Which of the following species will have 1 electron? Beryllium plus 3, if you see. When beryllium plus 3, N is equal to 2. That is the second shell. Okay, choice B will match with hydrogen atom. Next. An atom for which the electron probability distribution is spherical, symmetrical about the nucleus is. An atom for which the electron probability distribution spherically symmetrical about the nucleus is. That is 3s, because spherical, the shape of an s orbital or an s subshell is spherical. P is what? Dumbbell, and D is what? Double dumbbell. F is complicated. So spherical will be for 3s, and that is choice B. Moving to the next question. Which of the following statements in the relation to the hydrogen atom is corresponding, is correct or corresponding to the right answer? Which of the following statements? Let us see the statements. 3s, 3p and 3d orbitals all have the same energies? False. Okay, 3s and 3p orbitals are of lower energy. Okay, first of all, how will you verify this? How will you verify that which of the following orbitals of similar energies? Using n plus L rule. Let us see the first choice again. In the first choice it says 3s, 3p and 3d orbitals all have the same energy. Let's verify this. How? 3s, n plus L value is equal to what? 3. For 3p it is 3 plus 1, that is n plus 1 is equal to 4, correct? And for 3d it will be what? 3 plus 2. So which of the following statements are incorrect? Yes, so A is the incorrect statement. Their energies are not similar. Moving to the next question. Which of the following options does not represent ground state electronic configuration of an atom? Which of the following electronic configuration is not the ground state electronic configuration of the atom? If you see argon 4s2 3d9, that is for copper. What is the ground state electronic configuration of copper? For copper it should be what? It should be 4s1 3d10. Yes, it should be 4s1 3d10. So B is not responding to the ground state of copper. So B is the correct answer. Next question. If N and L are respectively the principal and azimuthal quantum numbers, N and L are principal and azimuthal quantum numbers, then the expression for calculating the total number of electrons in any energy level is given by which expression? Come on, look at the choices and decide. I have told you the expression to find out the total number of electrons. That is the summation of 2 inside the bracket 2L plus 1, right? Which is the choice? Choice D is the correct answer for finding out the total number of electrons in an energy level. Moving to the next question. 3D suborbital first occurs in the 4th orbit. It has what? When the 3D suborbital first occurs in the 4th orbit, it has what? All of the above statements are supporting, all of the above answers, that is choice A, B, C is supporting the presence of the 3D orbital in the 4th shell. Yes?